In this video, we're going to discuss volume and density. If you remember from our previous lessons, when we talked about SI units, we talked about measurements in length. We talked about meters. But if you recall, we didn't mention anything about volume or how we measure volumes. And so our most commonly used metric unit for volume is a liter and a milliliter. If you want to figure out what a liter is technically 1 decimeter cubed. So that means each side of my cube here is 1 decimeter long. And then as we know, 1 decimeter equals 10 centimeters. So if I take 1 square, 1 cube out of that whole big giant cube, that would give me 1 cubic centimeter, because each side of my smaller cube here is 1 centimeter. And it just so happens that 1 centimeter cubed equals 1 milliliter. And it just so happens to be that 1 milliliter equals 1 centimeter cubed. And so looking at our numbers on the side here, you might think I can easily convert from 1 liter down to 1 centimeter cubed. I just have to go through decimeters, so it's just 1 divided by 10, right? Wrong. Whenever you're doing volume, you have to take into account it's a 3D shape. So we have to take that 3D shape and the fact that our measurements are raised to powers, so we have 1 decimeter cubed, 1 centimeter cubed, we have to take that into account when we do our calculations. And so what happens when we perform our calculations that involve areas or volumes, we have to remember to square or cube the conversion factor. So we all know, or hopefully we all know, that 1 inch equals 2.54 centimeters. And that would mean I have a straight line here. Well, what if I want to talk about an area? Then I'd have to say 1 inch squared would equal 2.54 centimeters squared. Or what if we want to talk about a volume? So if I talk about a volume, I would want to say 1 inch cubed equals 2.54 centimeters cubed. Now, if you notice, I do a parenthesis around everything. What that means is the conversion factor has to be squared or cubed. So if I do my example here where I have the volume, that cube goes to the unit and to the number. So if I take that cube to the number and the unit, and then it also goes with the bottom ones to the number and the unit. So if I take that cube to the numbers and the units, this conversion factor would actually be 16.39 centimeters cubed divided by 1 inch cubed. So this would be the conversion factor I can actually use when I do my calculations. It's very important to make sure when you're doing a volume, you cube the unit and the number for the conversion factor. When it's just a line, you don't need to do anything. When it's an area, everything gets squared. When it's a volume, everything gets cubed. Not too bad, right? We just have to remember kind of our order of operation. I got to do the parentheses and the exponents before I do the multiplication for the calculation here. So now that we know a little bit about volume, let's talk about some derived units. So when we talk about derived units, those are units we get from other quantities. So an example, when you're driving, speed, miles per hour, that's a derived unit. Or if we talk about speed in general, it can be meters per second, miles per hour, kilomiles per hour, all of that would be considered a derived unit. Same thing with density. Density we'll see a lot in chemistry. Density is considered a derived unit, meaning that it is two other units we combine together to create our unit for density. So when we talk about density, that's the physical property of a substance. And the units we have are derived for the mass of that substance divided by the volume that it takes up. So most of the time we'll see density as grams per milliliter. You might see it as grams per centimeter cubed. Very rarely you'll see it as kilograms per decimeter cubed. We won't worry about that too much. But so these are different ways we can discuss density. One way to think about density is it's really just a ratio of a substance mass to its volume. So kind of how much stuff, or in our case, how much atoms take up a certain volume. And the more compacted those atoms are to each other, the more mass it can have, and the more density it has. So something with a very low density, like our first box here, that doesn't have very many green circles, or you can think of those circles as atoms. It doesn't have very many atoms for a certain volume. So it doesn't have very much mass for that volume. On the other hand, our high density one has a lot more atoms packed in there. They're packed a lot more tightly. So that way I can get a lot more mass within my same volume. And so when you're looking at density, we can rearrange our equation from D equals M over V. And within that, if I know two of these variables, I can find the third one. So you can think of it as density times volume equals its mass. Mass divided by density equals its volume. So all these are kind of different ways we can rearrange that same equation to find one of the three variables, as long as I know two of them. So now you should have a good idea of how to calculate volume and also how to calculate density, and how to rearrange density to be able to figure out the mass or the volume if you know what the density is.